Let's do exercise 4. I'm going to write a program that converts a positive whole number between 0 and 255 into a binary number. In case we didn't know what a binary number is, let's have a look at the explanation and see if we can understand the system. We're used to the decimal system, which is a number that looks like this or this or this. But the position is important because 16 is not the same as 61. Because the first position is for ones, and the second position is for tens, and the third position is for hundreds, etc. So it's the same thing, but they mean different things. They don't mean ones and tens and hundreds and thousands. So let's see. 1 in a decimal system is this number in a binary system. 3 is this number. 6 is this number. 9 is this number. Okay, we need some more explanation. Each digit 1 in a binary number represents a power of 2. And each 0 represents 0. So 0 is nothing, and 1 represents a power 2. So it depends on if they're here or here or here. They represent different powers of 2. So the first position is worth 1. And the second position is worth 2. The third position is worth 4. So we can see here that they're doubling all the time. So 1, 2, 4, 8, 16, 32, double that, 64, double that, you get 128. So the first position, 1, second 2, third 4, fourth is worth 8. And the fifth position is worth 16, or 2 to the power of 4, or 2 index 4, which is 16. The sixth position is worth 32, and this position is worth 64, and this position is worth 128. So for example, if we see a number like this, the zeros, we can ignore the zeros here. We just have to find out the ones, what they mean. The first position means that it's worth 1, and the third position was worth 4, and then we just add the numbers, so the total is 5. In this number, we have the second position and the fourth position. The second position was worth 2, and the fourth position was worth 8. So we just add them, and we get 10. Last example, we have 1, 1, 1, starting from the right. So we have, this is worth 1, this is worth 2, this is worth 4. We add them together and we get decimal number 7. Okay, now where we when we understand how it works, we can begin to think about how we can do this converter. They gave us a hint here. Use the percentage operator. Okay, that was about finding the remainder when we're dividing two numbers. So maybe we could use that. They gave that as a hint. So let's play around with the example a little bit to make sure that we understand how it works. So for example, if I enter the number 1, it should be 0, 0, 0, 0, 0, 0, 1 at the end. If it's a 2, it should be the second position. That is a 1. And then we can just double like this to see how the 1 travels to the left. Double that, we get 8. It should be the fourth position. If we have 9, for example, we should keep this and also add a 1, which was in the first position. That's correct. If we have 10, we should keep the 8 and then get the second position, which was worth a 2. So we can just play around a little bit to make sure we understand how it works. Let's take a number like this, 134. This means that it's 128 plus 4 plus 2, and that's correct. Okay. The idea is to take any number between 0 and 255 and chop this up into parts of 1s or 2s and 4s and 8s and 16, 32, 64 and 128. So build that number out of these numbers basically. And we had an exercise where we actually can access the solution, where we have to here, if we buy something in a store, the money we get back, we have to chop it up, the amount, into 100 bills, 50 bills, 20 bills, etc. So it's the same idea. We have a number and we have to chop it up, divide it up into parts of, in this case, hundreds, 50, 20, tens, etc. In our example, we have to divide this up, this number, into 1s, 2s, and 4s, and 8s, etc. In this example, we started with the biggest number, so 100 bills. So how many hundreds, how many 50s, how many 20s? So in this example, we're going to start to find out how many 128s in our number, how many 64s can we find in our number, how many 32s can we find in our number, etc. So let's stop this example and start with the design. We need a menu strip, file, and we need exit. We need a text box, we need a button, and we need nothing, well, a label, of course. Let's add a label. So I'm not going to do it here, but I would, if I don't have an idea already, I would download the solution and see how I divide this amount into hundreds, 50s, etc. So I'm just gonna give you the answer. Let's say this button should be named convert. Convert, enter. So let's implement this exit first. This dot dispose, and then brackets. So when I click convert, I have to take care of the number in the text box. Let's store it in an int variable named number. I have to parse it to change the string into an int. And text box 1 is the name of our text box, dot text. Now we take the text string in the text box, convert it into an int, and place it in this variable. Now we have to start to divide up this number into smaller parts. First, let's name the first variable N128. This variable will contain how many 128s we can find in this number. So to find out, we just take the number divided by 128. We have to remember one thing with the division in C#, that let's say that this number is 200. That's the number we entered. The result of this division will not be 1 point something, no decimals, because we're just gonna find out how many whole 128s can we fit in this number. and there's only one, and then we get a remainder, but that's not interesting right now. So 1/128 will fit in this number 200 if that was the example. So this will be 1. Now let's see, we have to kind of keep track of the remainder, so let's call it rem as a remainder. That will be number minus 128 times 128. Why? Well, because here we found out the number was 200 divided by 128. This will be exactly 1. The remainder will be 200 minus 128, and the way to calculate that is to take this variable, which contains 1, times 128, which is 128. So the number 200 minus this, and we get the remainder. So we should have 72 left. Now let's continue to find out how many 64s we have. So we take the remainder, divide it by 64, and in this case we had 72 divided by 64, and this will be exactly 1 in C#. So this variable will be 1, meaning that we have 164 as well. And then we have to kind of update the remainder, because now we had, let's see, 72 minus 64, so we're gonna have 8 left. So let's update the remainder is equal to remainder minus how many 64s we had times 64, and then we just keep going like this. I can actually copy this, and the next number would be 32. So let's paste 32, and then 16. And then 8. And then 4. And then 2. And then finally, how many 1s? And we don't really need to do this because if the remainder will be either 0 or 1, so we can just do like this. We don't need that last row, because after dividing this number into these units, we're just gonna have 0 or 1 left, depending on if it was an odd or even number. So we can just set n1 to the remainder. Now we can build our binary number out of these variables. These variables. N128 will either be 0 or 1. And this will be 0 or 1, this will be 0 or 1. So we have all the numbers here. Remember, the digit to the left is this number. So let's create a string. Binary number. That's the name of our string. And this will be, remember, we cannot just start typing this plus n64 plus n32, etc. Because this is a string and these are numbers. So a trick for that was just to add an empty string in the beginning, and then it's fine to add any number after that. Just a little trick that we have to remember. And 8 and 4 and 2 and 1. Okay, and the last thing we want to do is to write out the answer. So label dot text is equal to binary number. So let's try this. If we enter the number 1, it should be just zeros and 1 at the end, and we know that 2 is the second digit. Seems to work fine. Let's do some doubles. 8 should be the fourth digit. It's from the right. It looks correct. 16, etc. So it seems to work fine. So let's try a random number like this. 128 plus 4 plus 2 is 134. So this works fine.